7 notes. That's all it takes to create every song known to man. But it's not just the combinations of notes that go into making a melody. The series is repeated every 8th note in either higher or lower registers depending on their octaves. And it is this repetition that has a huge role in the creation of a musical piece. Does this periodicity exist in chemical world too? Let's find out. Hello and welcome to a very special show. Today we will discuss how elements are grouped according to their properties. We will study early attempts like Dobereiner's triad, Newland's law of octaves, and Mendelev's periodic classification. We will learn about the development of the modern periodic law, which helped create the modern periodic table or the long form of periodic table. Finally, we will talk about the questions you can expect in the exams with Exam Decoded. Today we will be taking a step back into history and retracing important moments that resulted in the ultimate classification of chemical elements, the periodic table. Be sure to follow this journey closely because many of its events may just pop up as important exam questions. 1829 Germany. J.W. Dobereiner discovered trends in certain properties of selected groups of elements. He classified elements into groups of 3 called triads. The elements in a triad had similar chemical properties and orderly physical properties. For example, the average atomic mass of lithium and potassium was close to the atomic mass of sodium. A similar pattern was found with calcium, strontium, and barium. Eventually, this law of triads was given up as it was impossible to arrange all known elements into this format. So why do we still study about him? That's because Dobereiner had made a very important contribution through his triads. He was one of the first to realize that atomic mass was a parameter in classifying elements. It would take at least 3 decades more for this realization to lead to the next significant discovery. 1863 England. Scientist John Newland first proposed that elements be arranged not in groups of 3 but in groups of 8 on the basis of atomic mass. Remember the music we heard at the beginning of the show? Well, it was precisely that which inspired Newland's deduction. Just as musical notes were repeated on every 8th note, so also elements exhibited a periodicity on every 8th element. This happened when they were arranged in the order of increasing atomic masses. For example, lithium and sodium share the same physical and chemical properties. Similarly, magnesium is 8th element to beryllium, hence both share the same physical and chemical properties. Newland called this repetition the law of octaves. However, with the discovery of noble gases, John Newland's octaves came to be largely discredited by scientists. Now, in the exams you may be asked why Newland's law of octaves was so significant even though it was obviously faulty. You see, Newland had hit upon the idea of periodicity. That means
that all elements with similar chemical properties appeared in regular intervals when arranged in the order of atomic mass. It was this realization that proved to be a milestone in the next major development, because, unknown to John Newlands, another scientist in faraway Russia had been working on a similar idea.
1869, Russia. Dmitry Ivanovich Mendeleev had also discovered periodicity. This had happened when he was closely studying the chemical properties of all 63 elements known at that time. He wrote the chemical properties and atomic mass of each element on separate cards. Then he arranged these elements in the order of increasing atomic mass. He noticed that elements with similar chemical properties were appearing at regular intervals.
Mendeleev called this repetition of properties the periodic law. Mendeleev also observed that elements in his arrangement exhibited a stepwise variation in properties. Chemically analogous elements either showed similar atomic weights like platinum, iridium and osmium, or they had weights which increased by equal increments like in potassium, rubidium and cesium.
By applying the periodic law, Mendeleev was able to predict the existence and properties of unknown elements, which he called Eka aluminium and Eka silicon. The elements gallium and germanium were later found to fit his predictions quite well. He also suggested the correction of a few atomic weights of elements. For example, he corrected the atomic weight of tellurium from 128 to being in between 123 to 126. This in turn paved the way for the correction of beryllium, gold and platinum.
Remember, if you are asked to describe these observations from Mendeleev's periodic table, you must give examples to support all the points. It's time for a break now, but before I leave, here is some trivia to tackle your gray cells. Mendeleev used the term Eka for unknown elements. Which language is this derived from? See you in the next segment with the answer. Welcome back. I hope you have been busy trying to answer the question I had left you with. Here is the answer. The term Eka that Mendeleev used to describe unknown elements is actually derived from Sanskrit, which means one. He also used the prefixes dvi and tri, that is 2 and 3. Let's get back to Mendeleev's periodic table.
When Mendeleev presented his findings in 1869, he revealed the complete structure of his periodic table. It consisted of horizontal rows called periods and 8 vertical columns called groups. Each group was further divided into 2 subgroups as 1A and 1B and so on. The properties of elements in the same subgroup were found to be similar.
Although Mendeleev had come up with one of the most sophisticated classification of elements till date, it still had certain limitations. And today's scholar has a query that sheds light on such a limitation.
Hi, I want to know why isotopes are not accounted for in Mendeleev's table.
Great question. Isotopes are elements with same atomic number and different atomic mass. So according to the periodic law, the same element must occupy two different places in the periodic table, which is really quite a contradictory arrangement. Luckily, a list of such limitations can actually help you score more, as it is a favorite question of the examiners.
Another limitation was that some elements did not seem to be placed with those having similar properties. For example, Mendeleev did not know how to justify the position of hydrogen. While he placed it in group 1 according to mass, its properties actually resembled those of group 7. In other cases, chemically dissimilar elements were placed together. For example, copper, silver and gold are placed in group 1 along with alkali metals lithium, sodium, potassium, rubidium, but there is huge difference in their reactivity.
Another blow to Mendeleev's table was struck in 1895. Baron Rayleigh reported the discovery of a new gaseous element named argon. This element was chemically inert and did not fit in any of the known periodic groups. Ramsay followed this by discovering the rest of the inert gases. In spite of these limitations, till the 1900s, the elements were still arranged by atomic weight in the periodic table. But its foundations were about to be shaken up. By the turn of the 20th century, scientists were beginning to look for another fundamental property besides atomic mass to classify chemical elements.
1913 England. Using X-ray analysis, H.G.J. Moseley showed that atomic number is more fundamental to the classification of elements than atomic mass. He went on to determine the actual atomic number of the elements and rearrange them in increasing order. In this light, Mendeleev's periodic law was modified and the physical and chemical properties of the elements were seen as periodic functions of their atomic numbers. Now, you should recall that atomic number is equal to nuclear charge or the number of protons in the nucleus. In a neutral atom, the number of protons is equal to the number of electrons.
So, can you now tell what actually affects the behavior and properties of elements and their compounds? That's right, it's the electron distribution or electronic configuration which determines an element's properties and leads to the periodicity of elements.
With Moseley's revolutionary discovery, the face of the periodic table completely changed. Today, we widely use the long form of periodic table. Elements are classified into horizontal rows called periods and vertical columns called groups. On arranging the elements in the order of increasing atomic number, the periodic table has 18 groups and 7 periods. As per IUPAC recommendations, the groups are numbered from 1 to 18, replacing the older notation. All the elements in a group have similar chemical properties. There are 7 periods. The first period has 2 elements and subsequent periods consist of 8, 8, 18, 18 and 32 elements respectively.
The 7th period is incomplete. Perhaps one of you could become a great scientist and help fill in the blanks.
1930 USA. The last major change to the periodic table resulted from American-born Glenn T. Seaborg's work in the middle of the 20th century. Seaborg discovered the transuranic elements from atomic number 94 to 102. This led to the reconfiguration of the periodic table by placing them at the bottom of the table in 2 rows of 14 elements each.
With Seeberg's addition, the periodic table finally assumed the appearance of what you and I today know as the modern periodic table. It was the result of constant questioning and seeking for the perfect answer. With this, our journey into the history is complete. Time now to secure your future. I'll be back soon with Exam Decoded. Hi, today's show has had us globetrotting across centuries, tracing the earliest attempts to classify elements right up until the present-day periodic table was devised. Here is a quick look at what we have learned.
Dobereiner classified elements according to law of triads. John Newlands developed the law of octaves based on periodicity of elements. Mendeleev arranged elements in the order of increasing atomic mass. H.G.J. Moseley showed that atomic number is more fundamental to the classification of elements than atomic mass. Modern periodic table is based on atomic numbers.
Now that we have defined the playing field, let's head for Exam Decoded. Welcome to Exam Decoded. Time to roll up our sleeves and dive right into the thick of exam questions. Let's begin with a rousing round of rapid fire. You know the rules. This round requires you to answer 5 questions with only 5 seconds response time for each one. Each question counts for 1 point, and these points will give you an idea of how your preparation is going so far. So let's get started. Your first question. Mendeleev's classification was based on atomic mass. Is this true or false? The answer, I'm sure you know, is true. Another easy question. The law of triads was based on atomic number. Is this true or false? The answer is false. De Boerooner's law of triads was based on the chemical and physical properties of elements as well as atomic mass. Your third question is, fill in the blank. The modern form of the periodic table was given by A. Mendeleev, B. Moseley, C. Newlands, and D. De Boerooner. The correct answer is B. Moseley, who based the periodic table on atomic number. Your fourth question is, the number of groups in the modern periodic table are A. 7, B. 9, C. 16, and D. 18. The correct answer is 18. And finally, horizontal rows in a periodic table are known as A. Period, B. Group, C. Both A and B, D.
Subgroups.
I don't think any of you would have got this wrong. The answer is A. Period. With this, we have come to the end of our round. As I said, your score is an indicator of how well you have prepared for this topic. 5 on 5 means you are a high flyer and are strong on the subject. 4 or 3 on 5 means you are an achiever who could do with a bit more practice. Anything less and you are a learner who must put in some more hard work. And the easiest way to do that is to keep watching this show and to log on to www.topperlearning.com for some more practice tests to improve your marks. Alright, time to get more specific about how you should tackle exam questions from this topic. Let's see how you can approach the topic of modern periodic law from the exam point of view. The unit, Classification of Elements and Periodicity in Properties, from which this topic is, has a weightage of 4 marks. So, it is important. You could be asked very short answer type question for 1 mark and short answer type question for 2 or 3 marks from modern periodic law. And since this topic abounds with facts and historic details, the most common questions are those which test your knowledge ability. So, it would be a good idea to brush up on the names of the scientists and the laws and classification they have developed. Here is an example of the kind of question you could be asked. List the drawbacks of Mendeleev's periodic table. This is a 3-mark question of average difficulty. Now here is the list of drawbacks, with each point worth half or 1 mark. First, the position of hydrogen was uncertain. Second, anomalous pairs of elements were placed together, tellurium and iodine. Third point is that the classification was based on atomic mass, so the position of isotopes was not clear. Lastly, chemically dissimilar elements were grouped together like copper in 1b and sodium in 1a, while chemically similar elements were placed in different groups like copper in group 1 and mercury in group 2. This is the complete answer that totals up to 3 marks. What other points do we need to be careful about when dealing with modern periodic law? Let's ask our expert.
We start with the classification of modern periodic law. I'll discuss with the Mendeleev's drawbacks. Position of hydrogen was not clear. Position of isotope was not clear. Position of lanthanide and actinide was not very clear. Elements having similar properties were placed wrongly. Elements having similar properties were grouped differently. These were some of the drawbacks that led to the formation of modern periodic law.
As you can see, it has taken several people across generations to come up with theories that we tend to take for granted in our studies. But I am sure that you, my students, take nothing for granted and remain focused and energized about studying chemistry. So keep at it and don't let me down.